All right, guys, yesterday we did where we graphed a system of inequalities. Today we're going to do the same type of thing, but these are going to be in word problems. Okay, so first thing we need to talk about constraints. So what a constraint is, it is conditions or inequalities that limit a situation. Now, we talk about those constraints in the word problems a lot because it's a real life situation. Okay, so if you're talking about running a mile, are you going to run that certain mile? Like, let's say I get up in the morning and I say, okay, I'm going to run -1 miles today. Would you ever say that? Can you run -1 miles? Or would I say, okay, I'm going to run a mile in -5 minutes today? No. So when we're dealing with these word problems, we have to kind of limit where the graph is going to be on the coordinate system. I can't even think what this is called right now. I'm sorry. Coordinate graph. This thing right here. Okay? So we have to limit the quadrant. So when we're talking about a real life situation, we're never going to be in the negative, ever. So we have to limit our graph to where x's are greater than or equal to 0 and where y's are greater than or equal to 0. Because again, just like my running example, we're never going to run negative miles, and we're never going to run those miles in negative minutes. Okay, so technically, if you look at this guy right here, we're always going to be in the first quadrant. When you are doing your word problems, you will always have these two guys as two of your constraints. You'll get your other two constraints, which are your inequalities, from the actual word problem. Okay, so does that make sense? These two will always be in your constraints because we want to be in the first quadrant because we're not going to deal with negative numbers. Okay? So now we have two constraints. We are going to find two more. So let's read the problem. It says you work a total of no more than 41 hours each week at your two jobs. House cleaning pays $5 per hour, and your sales job pays $8 per hour. You need to earn at least $254 each week to pay your bills. Write and graph the system of inequalities that show the various numbers of hours you can work at each job. So again, let's look at these constraints. Okay, if X is house cleaning, are you going to work a negative amount of hours on house cleaning? No, you're not, okay? So that's why we have to limit to the first quadrant. Same with Y, your sales job. Are you going to work a negative amount during your sales job? No. Again, that's why we limit the Y to the first quadrant, okay? So now let's set up two more inequalities. Remember, when you're doing your inequalities, your money should go together and whatever else they're talking about should go together. So let's do our money first. Okay, so it says I got $5. Let me scoot this over a little bit so you can see my finger. Okay, so you have $5 per hour for your house cleaning. So $5 per hour for house cleaning, 5x. Your sales job is $8 per hour, so 8y, okay? And it says you need at least 254. So what is at least as an inequality? At least. Good. Greater than or equal to. Now, at least is greater than or equal to because if they get any lower, they're not going to be able to pay their bills. Okay, so there's the money. All the money goes into one. Now, the other thing that they're talking about is the hours. It says that you can work no more than 41 hours. So with your house cleaning and your sales job, you can work no more than 41 hours. So what do you think no more than? Good. Less than or equal to 41 hours. Okay? You can't work more than that. So there's our inequalities. So let's look. How many constraints do we have? You have 4 constraints. 1, 2, 3, 4. Okay, 4 constraints. Now, when we were doing the other thing, let me switch my pencil. No, not yet. When we were doing the other guy, what we did is we solved these for y. So let's go ahead and do it. I'm going to move this 5x to the other side, which would make it a negative 5x. I'm going to divide everybody by 8. So we'll have negative 5/8 x plus, I'm just going to say 254 over 8 because it doesn't go in evenly. Okay, now when you come over here to this graph is not going to be set up to go down 5 over 8 because what we'll end up doing is you'll have your, let's see, we'll have our house cleaning down here. And we'll have our sales job over here. So when we count the hours that you're going to work here, they're going to be whole numbers. So maybe let's count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, and then 50. Okay? Same with here. Let's count by 5s because again, we're going to do hours. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So is this graph set up to go down 5 over 8? Down 5 over 8. Down 5 over 8. No, we're counting by 5s. Okay, so that's not going to help us. Doing y equals mx plus b is not going to help us graph it. So what other things have you learned? Because again, you have learned it. I've taught it to you. That you can do to get dots on the graph. Anybody? X and y intercepts. Okay, so purple first. I'm going to put them right here. All right, so let's start with x-intercepts. Remember, when you do the x-intercept, you are plugging a 0 in for your y. So I'm going to have 5x plus 8 times 0 is equal to 254. Just change it to equals so that we can just solve it up. So we have 5x equals 254. So x is going to equal, let me get my, what's this called? Calculator. So 254 divided by 5, 50.8. So meaning, remember how to do it? X is 50.8, and you plugged in a 0 for y. Oh, sorry, moved the little screen. All right, now let's do our y. So we're going to plug in 0 for the x this time. Trying to squeeze it in over here. So we have 8y equals 254. So let's divide. So 254 divided by 8, 3175. Now, you have an embedded assessment. Your embedded assessment has a problem just like this on it. And you have to do the x and y intercept because your graph isn't set up to do y equals mx plus b. So you have to remember that for your embedded. Now I'm going to plot these 2 points, and remember, then I just draw a line. This has a little less than underneath it, so I know that I can do a straight line. So I want 50.8. Let me scoot them over. 50.8 for x, which is a little farther than I want it to be. 31.75. Okay, and then remember, I just connect them with a good old line. All right, then remember, put your smiley face right on 0, 0. Let's come over here. Okay, so I'm going to put it right here. I'm plugging a 0 in for x. I'm plugging a 0 in for y. So what's going to happen to my whole left side? Yeah, it's all zeros. So is 0 greater than or equal to 254? Yes or no? 0 greater than 254? No, that's false. So remember, when it's false, don't shade with your smiley face. It does not work, so you do not want it in your solution. All right, first one done. Now I'm going to switch markers and come over here and do my other one. So I'm going to want to do my x-intercept and my y-intercept. So I'm doing this one right here. Just putting a little arrow down. So for x-intercept, I'm going to plug a 0 in for y. Remember, just change it to an equal sign. So I have x equals 41. So for this one, I know I get 41, 0. Let's do it for this one. Now a 0 in for x. Well, this one's easy, right? So this one's y equals 41. Okay, let's go over to the graph and get our dots on there. So over 41, boom, right there. 0, 41, oops, sorry, a little close there. All right, let's look at the inequality. It's got the less than under it, so I know. Ooh, you guys, that was sad. All right, let's put a 0, 0 in. So I'm going to have 0 plus 0 is less than or equal to 41. So is 0 less than 41? Yeah, it is. So I'm going to be shading with my smiley. Okay, so remember, just like the other one, what we do is we look to see where the purple and the yellow are. And they're actually right here. This one's got just a tiny, tiny answer right in there. Okay, so there's your answer. So again, remember on your embedded assessment, this one's on there. You have to be able to do x and y intercepts. Let's do number 2 real quick. It says identify 2 ordered pairs that satisfy the constraints and 2 that don't. So I'm going to say yes with a little arrow and no. So remember, if it satisfies the constraints, it will be in the shaded region, okay? The shaded region of both. So this pencil mark right here. So let's see. Let's go 0, 35. That would be in there. What about 5, 35? Yeah, that would be in there. So anything that is in this pencil shaded region is going to work. And then the no, it's anything that's not in the pencil region. So let's go 5, 5, because that would be here. That's not in the shaded region. Let's go 30, 45. That would be up here. So that's not in the shaded region. Okay, so yes in the shaded, no not in the shaded. All right, you guys, there's a couple practice problems in your little packet. So try those. And again, remember, look over the embedded assessment.